Now we're going to look at some special laws of exponents that's necessary for this particular section that we're about to do. We've got our negative exponent rules. Remember that if you have x raised to the negative n in the numerator, you can get a positive exponent by getting the reciprocal. Likewise, if you've got x to the negative n in the denominator, get the reciprocal, you get a positive exponent. So technically, wherever the value is, you get the reciprocal and you get the opposite of that. The other one, rational exponent rule, inside the crook of the elbow here, this is called the index, and if you've got an exponent here, then in order to rewrite it as a fractional exponent, which is what rational exponent means, the n, what's in the crook of the elbow, is always in the denominator. Whatever's here is in the numerator. I do have some examples that we need to look at before some other problems that I want you to actually work. So if I've got x to the negative 2, that's the same thing as 1 over x squared. Remember, I can put this over 1 and you get the reciprocal. Here I've got 1 over x to the negative 3, get the reciprocal, move it to the numerator, it becomes x to the positive 3. Remember, x to the 0 is equal to 1 as long as x does not equal 0. Now here's some radicals. This is a square root. It's understood to be a 2 in here. It's also understood to have x to the first. Since I don't see it, it's understood. So square root of x is the same thing as x raised to the 1/2. The next one, I've got negative 4 times cube root of x. So if I rewrite it as a fractional exponent, my coefficient is still negative 4, but the x is now going to be rewritten as x to the 1/3. This one, it's sort of a two-step process. First thing you have to do is change this radical to fractional form, and then I need it moved up. This is the actual form I need these problems in that we're eventually going to be doing. I need to see the coefficient times x raised to an exponent. So I've got some problems. You might go ahead and write these down and just pause me. I'm going to go ahead and say what the answers are, but I need you to write it down, pause me, you get the answer and see if we jive. In this first one, I'm going to move x to the 5th up if I need it in this form. So that would be 1 times x to the negative 5. This one, it's the x I need to move. So x to the 3rd would move up. The 1/2 is my coefficient. So I'm going to have 1/2 times x to the negative 3. Now I've got myself a radical. Remember where these numbers have to go. This should be 5 times x to the 3/7. This one, I need it in this form, so I need to see what the coefficient is times x raised to the exponent. So I'm going to pull the 8 out. That becomes a negative 1 over 8. The x goes to the back end, and that would be x raised to the 2/3. So that's how this would be rewritten, where I have my coefficient times x raised to exponent. This one, remember, you might have to do a two-step process, or if you can think your way through it, same thing. First, square root of x is x to the 1/2. I need to move that up, so this should be negative 6 times x to the negative 1/2. This one's a little bit easier than the last one. Move the x to the 7th up, so you'd have a negative 9 x to the negative 7. So instead of having a 5th root of x here, it was already changed to fractional form, but I need to move it up if I want to see my coefficient times variable raised to exponent. So I'm going to have 12 times x raised to the negative 1/5. Sort of can't see the negative, but it is there. Sort of blends in. This one, rewrite from radical form to fractional exponent form. So I'm going to have negative 12 x to the 6/7. So that's it for this lesson, and what we've looked at is very necessary. You need to know how to write terms in this form, where you have coefficient times x raised to an exponent. Thank you.